Again, good morning everyone, and thank you for the opportunity to present ProdVision at this chair at Anan. I am Dr. Anan Halabi. As mentioned, I am the founder of and CEO of ProdVision. And today I want to share a story about how we're solving one of the manufacturing most pressing challenges. And it's a challenge that it sits right at the intersection of explainable AI research and real-world industrial deployment. We are building explainable by design federated industrial AI for intelligent quality control. And we are doing it across different businesses. We are doing it in investment testing, we're doing it in medical devices, semiconductor, and precision agriculture. So it's across different businesses. So now, before I dig in details for the technology that we develop, I would like first of all to present the team behind the hard work which ProdVision will present in the later slide. So first of all, about myself. I am holding a PhD in mathematics. I have a long story journey in the industry, Israel industry. I worked for different leadership positions in quality management, reliability, in different positions in different sectors. I worked for HP, large format printing. I worked for semiconductor, and also I worked for medical device, automotive, and different jobs. Along this journey of leading different positions in quality and reliability, it was different occasions that in the floor I see problems recurring and defects, and all the time I ask myself, what is the source of these problems? And even if when the situation was very clear, it takes us a long time with the team to understand what is the source of this problem. And for this motivation, I founded ProdVision. The mission is to find very fast and very explainable the sources of this problem. Because imagine, when you are on the floor and you have a defect and you continue and you didn't understand the reason, you continue to produce 10,000 or 1,000 of components which are defect. This is a lot of money for the company. So beside me in the team, I would like also to introduce my colleague, my friend, Fuktran Kim, who is in the audience here. He is IAE senior member and international expert in explainable and trustworthy AI. Kim is a French Vietnamese scientist and advisor over more than 17 years in the area of AI research and deployment in the industry. Then I just want also to introduce our Director of Business, Han Fuktran, who is have a lot of experience, over 17 years in experience in strategic project management and AI-driven industrial optimization. Supporting all this, we have also multidisciplinary engineering and research, including PhD researchers in industrial AI engineering and data science, and front and back end developers. So what is unique about this team? We are we have also the academic area And we also have deep understanding how to take all this research to the industry and solve problems. And this is what is unique for the team in ProdVision. So, as I mentioned, ProdVision is taking all the theory, and we are now implementing our approach in with different leaders in the industry. We are, as a ProdVision, working in pilots in different sectors. We are working in vast casting manufacturer to detect anomalies in order to make the line more precise and to get the components with high quality for the aerospace and defense application. So these lines is very important because all the units which coming out of the lines is going to the aerospace and defense. And imagine these planes in the air have to be with very precise units with zero defects. So our application is now we are working with these leaders in the industry in order to build our solution. More than that, we are working also with leading medical device companies, and the precision here very critical because at the end of the line or very early we want to see that our products with high quality standards in order to send it to the customers, and we would like that these units that coming or products that coming to the customers with high quality in order to reduce the risk for the patient safety. The next is another pilot that we are working also pioneering agri-tech in inventor. Israel is now very pioneer in this area, and we working also in this sector. More than that, also we are working with another customer in the other area of the semiconductor in order to create high quality of PCB assemblies at the end of the line. So what is unique for all these pilots? You see, it's different pilots. It's from the investment casting. It's from medical. It's from pioneering agri-tech inventor, and also from semiconductor. What is unique for all these customers? They need explainable AI that help them in the line to come with products which we know that they are in high quality without problems. All these customers, they are need the explainable AI, which also we can trust and understand what is the defects early. And this is here, and here is coming ProdVision to give the solution. Okay, so why do these companies need ProdVision? First of all, as you can see in the floor, and I imagine that the picture that I'm giving you here, also people who work in the manufacturing in the floor understand that there's a lot of problems. First of all, as you can see, we have manual inspections and limited connectivity. People still working in the writing the inspection in the notebooks. In some cases, they're doing statistical SPC in Excel sheet, and all this is just slowing the quality response, and we have poor operational visibility. More than that, you can see that also, even if we have systems in the floor, so let's say we have SPC, and let's say we have another system of operation, EMC, all this system is not connected. The system is not talking each to other. So because the system is not talking each to other in the flow, what we can see that we have a drift in the process that we didn't see it early, and this drift is translated to effects at the end of the day. More than that, we didn't have, there's no real time monitoring. And this is translating also to recurrent of defects, waste, and financial losses. So without real-time quality intelligence, manufacturers face escalating costs, customer returns, and loss of competitive advantage. For sure, this penalty is translating to losing of about 5 to 15% of the revenue, the annual revenue, for scraps, rewards, and warranty. And let's say that this one of the customers have about $100 million. This number is translated to $5 million or $15 million a year, which going to lose due to scrap, reward, and warranty. Now I will talk about the solution. So what we at ProdVision, this is where ProdVision is coming to the place. So let's talk about the solution. So we, as I talked at the beginning, ProdVision addresses this challenge through an explainable by design federated industrial AI platform. So I will walk with you in the architecture of this platform and to tell you about the core of this platform. So if we're talking about the explainable deep learning, if we look at the middle of the slide, you can see that what we did is we connected to all the sensors, the cameras, the SPC monitoring, all this data which existed in the floor, we're not replacing, we just connected with. And once we connected with, we apply the explainable deep learning, which is a white box neural network to detect the anomalies or the deviation in the line. And this detecting is translating to the fact that we understand what is the cause of this problem. So as you look at these books at the up of this slide, you can see that the engineer understands what is the cause of the problem. And then he can take some action to fix the problem. So as you can see, this is the flow in the explainable deep learning. The unique thing here that we have some flow from the sensing up to the detection up to the cause. And this is very, very important because, as I mentioned, once we have only flagging, okay, you have the defects, it's not enough. And this is the solution that we are bringing to the table to our customer. Beside that, the platform, I will talk about the second core of this platform, which is the federating learning. As I mentioned at the beginning, so we need explainable AI. This is what I mentioned our customer need, but it's not enough. They need to trust that their data is secure, that the raw data is securing during the factory. And this is the federating learning. We create some learning in close to the station in the line, and there is existing all the manipulation and understanding and building the mathematical model. But after that, all what we transfer to the local server at the factory is not the raw data, it's not the imaging of the wafer, it's not the parameters of the casting process, it's only the insight or the math model that is transferred to the local server. At the end, this is protected our partners because our partners want to be sure that the raw data, the information that created in the factory is not leaving their factory. So what we transfer is the insight or the model to the server. And all this insight from different stations along all the line is transferring to the local server. What at the end we build is global model, which is at the end transferred back to the factory. So here what is existing is some learning between the models, between different factories. And this is the big new thing that we also adding to the platform is the federating learning that one factory can feed from the model of the other factory, and here is we are creating some improvement. So to summarize this course with this platform, we are talking about, first of all, real-time manufacturing AI platform, combining computer vision, statistical process control, and machine learning to detect anomalies early and improve quality. And also we have the explainable by design AI, which make every anomaly understood, and we understand what is the cause. And then the engineer can make the action immediately to solve the problem. And also the federating learning, which is another core in our platform, which causing some improvement and give the factory some proactive in order to prevent such problems in the future. So I just in this slide, I would like to explain how ProdVision use the hybrid layers in order to solve the problems of our customers. So our approach is including 3 layers. The first layer is we are building the knowledge in the manufacturer, all the area of the expertise, the standards of the quality, the manufacturing rules into AI models. In the second layer, we build the explainable deep learning, which is understanding, it's a white box network to understand what is the mechanism, what is the cause of these anomalies. And this is built in the first layer, because at the first layer we make the digitation of all the knowledge in the manufacturing, and in the second layer we build and understand what is the anomalies, and it's more than just giving some statistical model, because based on the first layer we can understand what is the physics or the cause of the problem. The third layer is the higher level, which is the improvement, because we want to move from just detection and understanding to some layer of preventing. And this is the third layer, which is in our platform. Okay, I'm moving to the next slide. So, explainable, just a minute, I would like to, 1 second. Yeah, so explainable by design, federated industrial. So, I just will go over the architecture to just give you sense how this architecture is built and how we can use it at the end in the business to the business impact. So as I mentioned before, you can see in the middle of the slide, we have in the factory edge 1, edge 2, edge 3. Each of these edges is the local sensing. It's collecting the information from the sensors, from the cameras, from all the sensing in the line. And here at the edge of these edges, a computation is happening in order to build some insight about some anomalies shift in the line. After we create this phase, all the information, when I'm saying information, all the models built here in these edges is transferred to the local server. So as I mentioned before, we are not transferring the raw data, we are not transferring the image of the wafer, we are not transferring any raw data or parameters of the process. All what we transfer is the model to the server. Now, from each one of the stations is just example of the architecture, but for each one of these edges, all these models or insight is translated or transferred to the local server. At the local server, here also happening another process that all these insights which coming from the edges is from them we are building global model. And this global model can be also shared, collaborated with another factories. So pay attention, we are not sharing the information or the data for each factory. What we can collaborate is the model that we built from one factory to the another factory, and it's giving us opportunity to improve. And here is very important, our partners have very sensitivity to the data. And this is the unique thing that ProdVision is giving. We are giving protection for the data of the factory. It's not moving outside. So at the end of the day, this architecture is giving us added value of protecting the data, and also we are understanding, we can learn or improve from one factory to the other factory, and at the end of the day, we reduce human inspection error, predicts production drift early, and deliver quality improvement for real-time anomaly detection. So this is the architecture that we are talking about. Maybe just a little another point that I would like to mention. As you can see from the hardware, in each image we have the camera model and the AMD Versal AI core. And this hardware is very, very compatible to be adapted in different lines or different businesses. And this is what we are doing in the different pilots. So just after we talked about the architecture, I would like to share with you the key benefits of our solution. So we mentioned it. First of all, we are talking about explainable AI, and this is very, very unique to this platform. We have transparent anomaly detection. We now understand what is the cause of the detection. It helps us very fast do some action. Engineers have the ability to do some action to solve the problem. More than that, it is very, it serves another mission. In medical business, it can be meeting some auditing requirement, regulatory, and this is the third bullet. Another area that the platform is providing is data confidential. So we talked about the production data is remain local in the factory. It's not sharing the service. All the sensitive data is protected. Secure collaboration across production sites. And not more, it's very important also, compatible with existing factories. We didn't change all the infrastructure of the factories. And this is very important because businesses don't want to start investing a lot of money in new technology. We are compatible. We didn't make a lot of changes to the factory. We take the factory where it is, and we just adapt our technology. So this is this is the key benefits from our solution. Okay, so let's talk about why we are talking about this platform today. So first of all, let me just give you some sense about the market. So if you look at smart manufacturing, as you can see here, we are reaching $48 billion in 2029. We have a compound annual growth rate about 15.5%. And this is a good trend, but if we would like to look at ProdVision is playing a key roles in different key players. First of all, ProdVision, as you can see, we are talking about global automatic quality inspection. And here also we are reaching $46.71 billion in 2034. And here also we have some growth, compound annual growth rate, about 8 or 12%. In the computer vision, we have also we are hitting $72 billion in 2031. We have again some compounding annual growth rate about close to 16%. And if we're looking at the AI, we are here searching we are searching to $20 billion at 2028. And all these trends in the market, which ProdVision using all these parts or playing key roles in these sectors, we see that companies is searching for big solution in AI to solve real problems in their flows, in their manufacturing. Now I will take you to another area of how ProdVision in the competition and positioning. So let's look at the traditional vision. So in the traditional vision, we have some key players like Cognis, Keyence. They are very, very strong in cameras and hardware. They are very strong in deploying a reliable solution to their customers. But they are lacking. They didn't have AI learning capability. They have no cross-factory learning. All this thing is missing from these very traditional vision vendors. If we look at the AI vision inspections like landing AI or Inspector or another competitors in this, another key players in this segment, they are good at AI-based defect detection. They're easier modeling training. For example, landing AI, you can, even people who didn't know anything about computer vision, they can train a model. But what they are missing is the limiting process understanding. They have no understanding for the process. They have weak integration with process data. And here ProdVision giving all what is missing in these two segments. We are in ProdVision giving explainable AI. We understand what is the cause of the defect, and this is very, very important to our customers. More than that, the federating industrial learning. We can learn from one factory to the other factory and improve. And more than that, we have the integration, the process intelligence, which is the SPC plus the AI. So let's talk about how the company building the revenue, the business model of this company. So first of all, we are talking about project management. We deliver full turnkey implementation for production facilities, including customized quality control systems. Revenue comes from a project setup, hardware and software, integration and ongoing maintenance service. This is one part of the business model. The other part, once we deploy the platform, we make revenue from the usage for our customers and the support that we give our customers for these platforms. And as you can see, ProdVision is making the revenue from this hybrid business model, and we are now scaling globally from Israel across Europe and Asia and industrial hubs. Now, at the end of this presentation, I would like to share something, my thoughts about where we are at this process. So first of all, I would like to share with you that manufacturing is playing very critical role in the economy. The manufacturing is by manufacturing, we are building saving life devices which transferring to hospitals. By manufacturing, we build a lot of all the food in the world. So the manufacturing is playing a huge role in all the economy. So, but still we see a lot of money that these factories is losing. And why they are losing this money? This is because they have the technology, but the technology is not giving them the opportunity to understand what is the sources of their problem. They didn't give them the opportunity to protect their data. They didn't give them the opportunity to protect their data, and they didn't give them the opportunity to improve their processes and to be proactive and to save this money. And this money can go to research and other activities of these companies. But because they're lacking this technology, which ProdVision provided today, they're losing a lot of money, as I mentioned, about 5% to 15%. It's a huge numbers.
Thank you, Dr. Halabi. Thank you for sharing with us and all attendees your vision about architecture and cutting-edge solutions about quality control using AI. Are there any questions?
Dr. Halabi, so this is Wei Wu. I'm actually from Silicon Valley. Also, I have a company in China. So I understand you have your AI algorithm located at the edge, right? And you also have the local server to connect all the distributed edge devices. So my question is, what do you have? You also mentioned that when the algorithm fails, you use the human to correct the data. My question is, what's the mechanism? Do you have an automatic mechanism to correct failure data, which will be used for the future lending, right? You will, I believe you will transfer the data to the server, then to the lending, and distribute it to the edge devices again, right? That's the common algorithm. So, do you have an automatic mechanism to do that?
So what I can tell you at this stage, as I mentioned at the beginning, we are now in some pilots. We are on some progressing pilots. I think this challenge that you are mentioned, it can be divided to two parts. One part is not just either, or just you fix it in the local or in the server. I think the best way is we are learning this how to manage these solutions. It can be either. It can be that you can fix it manually, and it can be also fixed automatic. So it's depending on the situation. I cannot say that we have one solution. I think each solution can be fitting to the situation that we are dealing with. Is it answering your question?
Yeah,
Thank you. Other questions? Okay, I thought that there was also an important issue that you address with your solution, because process drift as well as quality control has also a great impact on the environment, because the reclaiming from customers has also a great impact. So I guess that detecting very soon very vicious process drift also has this is really also nice. Yes? Do you share? It is costly, and also it's really important. Okay.
Just one last comment. So I will be glad to hear from the audience for future collaboration. If you want to deploy and to discuss, if you have some, if you want to deploy such a solution for quality control, or to have some collaboration for research and so on. So this is our details here, so you can contact us.
Thank you.
Thank you.
So we have now come to the end of this session. Morning presentation have provided us with a broad and insightful view of current advances in AI and its real-world application, from academic research and industries, from AI-assisted engineer system and the integration of the AI with robotics, industries, the medical imaging, intelligent license plate recognition. We have seen how AI technology can continue to transform both research and industry, and highlight the growing impact of the AI across diverse sectors such as healthcare, manufacturing, environment, and smart industry. On behalf of the organizing committee, we would like to sincerely thank all presenters and participants for their valuable contribution and engaging discussion. So we hope this presentation inspire new ideas, collaborations, and innovation in the future. Lunch will now be served. We kindly invite all participants to enjoy the lunch break and return here at the Edison Hall at 2 p.m. for the afternoon technical section 2 on smart health, smart education, and smart manufacturing. So thank you and enjoy to learn.
Thank you.